Okay, I'm starting recording and I forgot I had my GoPro hat on. This is what I plan on doing some video content in on machining and actually in here. So I got the back cover open so you can hear the audio. I did some videos before where they covered and the videos are nice, but you can't hear anything. So, but this works out good. This one actually used to be on my motorcycle and it fell off drag racing, but I was able to glue another one back on. And somebody years ago, I think it's Zeth Rose, left this clip behind. Nice hat clip. Okay, I'm going to do a commentary over somebody else's video, so because it's just as good as me doing it, and it's actually an older machine. So I'm going to play this video, and I'm going to start and pause it, and I'm actually going to just mute it anyway. It's actually from a friend of mine's school in Worcester, Massachusetts, Worcester Polytech Institute. My brother actually went there to get his master's degree in civil engineering. So, and Toby, they do they're an engineering school, 4-year engineering school. So, anyway, I hit play. Okay, this is his instruction manual for doing, let me move my face up here. Alright, CNC lathe, older Haas lathe, pretty typical. This has a collet arrangement here, and this is the turret. And whatever tool is aligned, this is called the slant bed lathe, so sometimes it could be, for a beginner, it's hard to tell which tool is actually lined up with the spindle. The spindle turns in the same direction as the regular manual lathe, but the tools are on the other side of the turret, spindle, so. And they're actually upside down. There it is right there, and there's a little coolant hose right there. All right, I'm just gonna hit play, and we have an air-operated tool setup, but pretty much most of them are manual, which means you manually bring this down. That could be Haas or any other brand. This square here is the calibration tool. We've been using something called Auto Probe, which we put the tool right here, and we just hit the cycle start button as long as we get all the settings correct. And it beeps the Z-axis and the X-axis for tip direction 3. And that's the most common one. In this video, I call it manual probe, which means you're going to bring the probe tip up and you have to switch, which is not shown in this video. You're not going to use the hand jog wheel. You're going to get it close and put the jog increment on 1/1000th, 001, and then you're going to press the Z negative direction on the jog button, which is like the selection of the axes, but you're going to press and hold, and it's going to keep on traveling until it hits that. It won't over travel. You'll beep, and it's going to put in the number in your offset page. So you could do Z and X. All right, let's play. Oh, okay, so here's your offset page right here. It's an older machine. It's still set up the same way. These are X and Z columns here. So they're manually bringing this tool over. Bring it down. And bring it closer. Bring it closer. And then you have to switch to the jog mode, which is not shown in this video. That's a difficult thing about doing videos. You'd have to have dual cameras running at the same time. But I can talk. So now this is press and hold, and it's updating the Z. This is Z, that's X. So you're going to pull it away, right? Bring it up and over, and you want to hit this side. But remember, it's not you cannot do it with the jog handle. You got to do the press and hold, and you got to be in the 1/1000th increment. Don't be in the 1/10th increment. That'll take forever, and you don't want to be in the 10,000ths or the 0.100 increment. It's going to be too fast. You don't want to break this thing off. But this is going to set the coordinates. This is X. This is calibrated so it knows where the center of this spindle is. And the Z will actually be where this is. And then we'll use the work offset to get it to go from here to wherever this material is. This will be your variable. And notice that they pulled the tool back to rotate and change tools. I actually found this pretty interesting because if you watch somebody else's techniques, you think they're all similar, but not exactly. So you kind of have to learn the culture, the tribal knowledge of the shop. This is a cutoff tool. We can tell that's a cutoff tool there. And I'm always probing from the right side and top. It's going to depend on your program. So if I'm on manual lathe, I am touching off on this side of the tool, and the cutoff will be, I have to add in for the width of the cutter. I have to add in a little bit more. So in my program, I'm set up that way, whether it's manual G-code or CAD/CAM generated G-code. So how you select, now they're probing the other side. So you got to know how it's programmed in order to do this. So personally, I'm on the side, this side guy, and I'm adding in for the width of the insert. So you got to be aware of these subtle differences. Nobody wants to crash anything. So, all right. So this is going along. So that's like turning tool. This is cutoff tool. Pull it away. We use the home button to bring it all the way home, and then rotate and change tools. So they put this away, and then I think they're going to add for drill here. I think they got ahead of themselves. So now they're changing tools using the MDI command, and there's a drill right there, right? Now, the difference on CNC lathe and manual lathe is a manual lathe. Let me just pause that for a second. Back it up just a smidge so we can have a picture. Is that we're always drilling with the tailstock. Tailstock's lined up with the spindle. All the tools are in the turret, so you got to align the drill to the center of this. Some people will guesstimate it. They'll go up and literally drill until the drill doesn't bend. I've seen that. Some people will put an indicator on this side and indicate this, and then figure out what the coordinate is. And all of these tool holders, all these positions, whether they're a bolt-on arrangement or they have a hole in the turret, they're all exactly the same. So once you know that number, you could just put the number in, because you don't really need to whip out the indicator all the time to do that. And I've literally seen it like written on the side of the machine in magic marker, like all drills use this X coordinate. And Haas actually knew that, and they actually put in a button. Oh, I'm pressing the wrong screen. All right. So if you press the F2 button in a Haas, it already has the number stored, and it's going to put it in there. But we still need to set the Z coordinate. We only have the X. The X is center of drill to center of spindle. So probably should have just left it down, but you're learning. So, all right, so you're going to bring this down, and you're only going to touch the Z. You do not want to touch the side of this, because you'd have to actually calculate the width of the drill and if it's actually running true or not. So no need to do that. We only need to use the Z coordinates. So if you're not using the auto probe system, but you're using the probe, same thing. You would put it in 1,000th increment and press Z negative. Just press and hold the button until it beeps and it updates that number. You kind of want to be in tune if the numbers are updating, you know. If you start with 0, then obviously you can see them update, but usually you're just resetting tools, so there's already going to be data here. So you want to be in tune with that, you know. And on a lathe, you're probably not going to change all the tools all the time. You might change drills, boring bars, but your common lathe tools will probably just be in there all the time. And you might be just changing the inserts, unless for some reason you check it out. So what else we got in the, this is his checklist, which I actually made a checklist based on his. He has got a very good checklist. So they're looking in their CAM software. All right. So whether you're in CAD, CAM, I'm not sure what they're using here. Probably can figure it out. And then simulate on the controller, which is our same method here. This is just an older controller, so you want to see if does it look correct. And I noticed these moves here. So these dotted lines are rapid moves. And so they're going up for the tool change position. So they're not going all the way back. They're just going up enough to clear. Right there, and that's a position move coming down. So in our school, we remove the part and then run the job with coolant off, because on the CNC lathe you can't see anything in the window. It just the coolant is flashing so much, and some of these lathes you can't even see through the window anyway because there's been chips bouncing on it all the time. So if we remove the part, the whole goal is not to hit the collet or the chuck. So if you can do that and verify that it's not going to hit anything, then put the part in at proper stick out length, and then you can run the part, because everything you're going to be hearing is the cutting of the tool, and then you can toggle the coolant on and off to check on things. And then go to distance to go. That's a standard, because you want to stop on your way down there and check your distance to go. This is kind of a verification of, did I set the tool offsets right, or the Z shift. So, all right, let's just go ahead here. So this is a pretty good little video here, because they're, on this screen here, you got all your different things: spindle speed, feed rate. These are common commands. So this has got like a multi-screen page, even though it's a one-page thing. Not like the next generation of the control, which is not the next gen control, but the classic control. So you want to check first time around, first time at a rodeo, as my buddy Rick Steiner says. You want to check all this stuff, make sure it looks correct. Personally, I like changing from way up in the tool change position, so I wanted to approach, but all right, so this is just a straight, looks like a pecking cycle, G83 pecking cycle. Just remember, in a lathe, it's inches per revolution, so this feed rate is going to be a very small number in thousands, different than mill. All right, come down here, so we got turning tool. You just double check your distance to go. Make sure you got this is the brake, the red is the brake and the green's the go, gas and brake, If you got it on CAM, simulation, you ran it once with nothing there, then you should be good, Personally, I would say, boy, I wish the chips were breaking, but, this is kind of like what you don't want to happen, because eventually they're going to get wrapped around the part or the tool. So, but those are the things you can diagnose. That's what you're there for. They're also the troubleshoot. Number one is your surface finish good? Number two, why aren't the chips breaking? Maybe the insert has got built up metal on it, built up edge. Okay, so there you go. So they had turning tool, drill, and cutoff. So I really wanted to make this kind of short, but I thought this was a good video to just do a talk over on prove out. I call this the prove out. You did your setup, and now you got to prove it out. Now you're actually making a part. Proving out would make sure the program works as intended, whether you programmed it or somebody else did. So, and as a programmer, you want to help the guy as much as you can, because you want to program and pass along information as you intend somebody else to do it. Oh, there we go. WPI Haas Tech Institute H-Tech. I thought I'd be able to see these guys this year. All right, so this rolled into my I have a YouTube channel, and this was the next video, which is this is a TL1 lathe, and I can get into that also, but I'll do that one separately. This is like normal lathe, but CNC control, and the red handles are really electronic handles, so they're not mechanical handles, but you can do manual machining on there. Okay, that's it for me. Talk to you later.